Okay, we're in section 8.6, exercise number 12. Just like exercise 10 a moment ago, or the previous exercise, we are being asked to determine the values of x that make this particular power series converge. Notice this is a power series now, not in x, but a power series centered at -4 in this case. So this has a c value. So this is a power series centered at c equal -4. So we don't see powers of x in our expression, but instead we see powers of x minus -4, or x plus 4. And so our series looks like when n equals 0, 1 is our constant term, and when x equals 1, we see x plus 4. Then we have 1, 2 factorial, x plus 4 squared, 1 over 3 factorial, x plus 4 cubed, and so on. So the series is expressed in terms of powers of x minus -4. So as we find our radius of convergence, we're looking at -4 and looking for some sort of r value that determines the values for which the series converges, and then the interval of convergence will be centered at -4 as well. All right, so just as in the previous example, we studied the convergence by applying our convergence test. We'll look at the ratio test again and try to determine which values of x will yield a result of the ratio test that imply convergence. So we'll take our limit as n goes to infinity of x plus 4 to the n plus first power divided by n plus 1 factorial. That's the numerator of our ratio. And then we simply have the x plus 4 to the n over n factorial. It's our denominator of our ratio. You should have some good practice at this point simplifying these expressions from our previous sections, but I'll go ahead and write out the details. So if we simplify before looking at the limit, we have all these x plus 4s canceling with all but one of the x plus 4s in the numerator, and then the n factorial canceling with all but the largest term in this factorial, leaving just an n plus 1. And so we have 1 over n plus 1 x plus 4. Now notice, regardless of the value of x, this coefficient term is going to 0 as n goes to infinity. And so this limit is 0. It's 0 times x plus 4. No matter what value of x we might plug in, we're going to get 0 times that x value plus 4. And so our limit is simply 0. What does this mean? Well, no matter what x value we plug into our series, it's going to yield a series, that we plug into our power series, it's going to yield, so no matter what x value we plug into here, it's going to yield a series that when we apply the ratio test, results in a limit of 0. That implies convergence. 0 is less than 1. And so we have a series that converges for every value of x. Has a radius of convergence infinity, and so the interval of convergence is the entire real line.